Hello students, Deepak here. I welcome you all to this new course that is launched by TEXAMEET, that is concept through questions. Okay, so the subject that we are going to deal is the elements of civil engineering. Okay, so one by one we will see the different MCQs on the different topics that are mentioned in the syllabus of the Maharashtra Engineering Services pre-exam. Okay, so today we are going to deal with the MCQs, that is multiple choice questions on the cement and sand. Okay, this is the first session and later on we will going to for the second session. Okay, so one by one we will see the different questions and try to figure out their correct options. Okay, so very first question here is the read that question carefully. That is, the major constituent of the cement is. This is the simplest question. Okay, this is the simplest question. I am here going to increase the level, okay, step by step. In the next module we will going to deal with the some of the difficult level questions. Okay, so these are the basic questions, but students also get confused with the options of this such a simple type of the questions. So the question is, the major constituent of cement is. The options given are the lime, silica, alumina and iron oxide. I think you all know the answer of these questions. I have also prepared a table over here. So this is the table of that cement constituents, and you can see the oxides here and their percentage content. So the first one is the lime, correct, then silica, then aluminum oxide, then ferrous oxide, magnesia, alkalis and SO3. So this is the simplest question, and you can see the percentage is also given. So the first one is the lime and its percentage is 60 to 67%. 60 to 67%. So the correct option here is the first, that is the lime. Okay, lime is the correct option, that is option A is the correct option here. Now the question on this topic may be asked like that, the percentage of the lime, okay, in OPC it is generally between the range, or they may ask direct value. In that case you should remember this range and should calculate the average value. So here you can see this average value is between 64 to 65%. So this is the correct answer at that time. Now next see the another question. So the next question is the constituent which impart strength to the cement. Now they are asking the constituents which actually imparting, see, read carefully, impart strength to the cement. That means it impart the strength. Now if you see that constituents and their roles or their contribution in development of the strength, here again I have prepared a table, so you can revise that. So here is constituent, after that their use or imparts, and if it's in excess then what will happen with this cement or that structure. So the first one is lime. You can see it imparts strength and soundness. Okay, and if it's in the excess then this cement becomes unsound and it will obviously disintegrate. So one by one the constituents role is actually noted down here, so you can keep that table in mind so that you are able to solve the numericals or the questions on this point also. So they are asking which imparts the strength. So lime, silica, alumina and magnesia, 4 options are given. So you can see that the lime, correct, the lime is the correct option here. Okay, lime is the important part that imparts the strength to the cement. Obviously silica also imparts, but here the most correct option, most appropriate answer is lime, as most of the strength is actually contributed by this lime. Okay, now next see another question over here. So the next question here is, read that question. What is that question? The constituent which imparts color to the cement. Okay, the constituent which imparts color to the cement. Now if you observe the table over here in the last slide, okay, the table. So the color, okay, the color contributing element here are the iron oxide, correct, iron oxide, and the next one is the magnesia, iron oxide and the magnesia. Now you can see from this option you can clearly identify the correct option, that is the iron oxide. Okay, iron oxide is the color imparting constituent in case of the cement, and color is brown. Okay, it gives the reddish brown color to the cement. Now next see the another question. Read that question. The rotary kiln used in manufacturing cement rotates at a speed of. So it is actually the cement manufacturing process question. Okay, so they are asking the rotation speed. Okay, the rotation speed of the rotary kiln. Okay, in that kiln the clinkers are actually formed. Okay, the clinkers are formed, and after that they are granulated with the gypsum in order to get our the final product, that is the Portland cement. Okay, you say that Portland cement. Now the question, what is the question asking? The rotation, okay, rotation speed. So the options are 1 to 3 revolutions per minute. The next one is the 10 to 12 revolutions per minute. The third one is the 18 to 22, and the last one is the more than 25. So remember always, the speed or the rotation speed of that clinker is 1 to 3 rpm. Okay, it is 1 to 3 rotations per minute is the correct option over here. Okay, so this is the correct answer. Now next, let's see the another question here. What is that question? The clinker is formed at a temperature of, okay, the clinker is formed at a temperature of. Now you all know that the manufacturing process of the cement, correct? You must have read that. So here the calcareous and argillaceous material mixture is prepared, okay, their slurry is prepared, and depending upon their contribution, or we can say the percentage, and they are given the higher temperature, and after that they form the clinker, correct? Clinkers are nothing but the nodules of size 3 to 20 mm. Okay, these are the nodules of size 3 to 20 mm. Now the question here is, what they are asking, the temperature they are asking basically. So the temperature here in the that rotating kiln is around 1400 to 1500 degrees Celsius. Okay, it is around 1400 to 1500 degree Celsius. So this is the centering temperature where the both constituents are combined, okay, in order to get the clinker. So the correct option here you can see is the D option, that is the 1400 to 1500 degree Celsius. So the clinker is formed at that temperature. Okay, the clinker is formed at that temperature. Now next, let's move to the next question. The question here is, read that the amount of gypsum added in the manufacture of the cement. The amount of gypsum added in the manufacture of cement. Now this is, I said in the last slide that after the formation of the clinker, they are grinded, correct? They are grinded, and with addition of the gypsum, okay, with addition of the gypsum, and this gypsum percentage is up to 5%, up to 4%. Okay, it is up to 4%. So the correct option here you can see here is 0.1 to 0.5. Now why the gypsum is added? The question is, why gypsum is added? Actually, the present, due to the alumina present, what happened? It sets quickly, and in order to retard, okay, in order to retard that procedure of setting, the gypsum is added. That means there will be enough time in order to mix the cement with along with other constituents of the concrete. Okay, so here the correct option is the option D, that is 3 to 4%. Okay, 3 to 4%. And here I have shown the manufacturing of the cement chart. So you can see it is about the wet process. It is about the wet process. So here is addition of 2 to 3% of the gypsum is here. So this is the value, general value range, that is 3 to 4%. Okay. So now next, let's move to the next question. So the next question is again about the gypsum. What is the question? Gypsum is added during the manufacture of cement. Gypsum is added during the manufacture of cement, and the options given are, the first one is while okay, the question first is while mixing the raw materials. The next one is during burning in the kiln. The third option is at the beginning of grinding the clinker, and the fourth option is after grinding the clinker. Now tell me, in the procedure I have said that I think in the second slide I have told that in case of the gypsum added when the clinkers are already formed. Okay, the clinkers are already formed, and the clinkers are formed at the burning stage, correct? These are formed during the burning stage. So while mixing the raw materials, it is the not correct option. The next one is the burning in the kiln. This is not the correct option. At the beginning of grinding the clinker, yes, this is the correct option, correct? When the clinkers are formed, then these clinkers and the gypsum is actually combined and grinded in that mill, okay, ball mill or the tube mill. So this is the correct option, that is the beginning of the grinding the clinker, that is option C is the correct option here. Now next, move to the next question. What is the question? The question is the specific surface of the cement is, okay, the specific surface of the cement is, and the options are measure of fineness, measure of volume of cement, measure of smoothness of cement, and none of the above. So the correct option here is the measure of fineness, because if you see the specific surface, it is given in centimeter square per gram. What it means? It means actually that what is the area, okay, what is the surface area that is occupied by this 1 gram of cement particle or the constituents. Okay, so this is the case. So this is the measure of fineness. And why this specific surface is important? Because this is important as per as strength development is concerned. Okay, this is important as per as strength development is concerned. That means more the fineness, so more is this value, that is this surface area. And in that case, so the rate of hydration will be the higher. Okay, the rate of hydration will be the higher. Actually, it doesn't hamper the total heat of hydration. Okay, it doesn't hamper the total heat of hydration. It only increases the rate of hydration of the cement. Okay, so this is about the specific surface area, and this value in any case should not be less than this value, that is 2250, that is 2250 centimeters square per gram. In any case, this specific surface area should not be less than this value. Here are also some important point I have mentioned here, such as lime saturation factor. So what is that lime saturation factor? It is the ratio of lime to the silica, alumina and ferrous. Okay, though so MCQ may be formed on such a type of question. We will see that later. Again, some of the important points I have given here. So this is the correct option of this question is option A, that is the measure of fineness. Now the next question here is the specific surface. Now the same question I repeats here. The specific surface of a cement should not be less than, that means it's related to the specific surface. And as I said already, that in any case it should not be less than this 2250 centimeters square per gram. That is the option D here is the correct answer. Okay, option D is the correct option here, that is 2250 centimeters square per gram. Now the next question here is the compound responsible for initial setting of the cement is. Now read the question carefully. I think many of the students gets confused with that. That is initial setting and initial strength development. These two are different things. Okay, these two are different things. So the question asking is about initial setting of cement. It is not asking about the initial strength. Okay, so the correct option of this question is option A, that is the tricalcium aluminate. Tricalcium aluminate. This is the first compound in the cement that actually reacts with the water, and it's react with the water, and the initial heat of hydration is due to this compound, that is the tricalcium aluminate, and due to that initial setting happens. Okay, and in order to retard that setting we add gypsum. Okay, clear? So in order to retard that, sorry, let me write it clear here, gypsum is added to retard the process of setting. Okay, initial setting due to that tricalcium aluminate. So this is the correct option here. And if I say the initial strength, then in that case the correct option here is tricalcium. The second option will be correct here in that case, that is the tricalcium silicate. And in this case they are asking about only the initial setting. Okay, so the correct option over here is the tricalcium aluminate. Okay, tricalcium aluminate. Now these all compounds are nothing but the bogus compound. Correct, you all know that these are the bogus compound. Here again I have noted the some of the important points regarding these bogus compounds. One by one we will read that. Okay, so what are these points? The first one is the tricalcium aluminate, that is C3A, as we discussed the above case, that is it leads to the quick setting. Correct, it leads to the quick setting, and its hydration is within 24 hours. Okay, its hydration is occurs within this first 24 hours, and that means it ultimately leads to the setting. Okay, initial setting. It also has the high heat of hydration, and that leads to formation of the cracks. Okay, now suppose this is the cement element, and in which there is this tricalcium aluminate at the inner core. Okay, inner core. In that case what happens, there are pores are present, and this pore contains actually the water. Now due to this heat of hydration, okay, due to this tricalcium aluminate, there the water get evaporated. The water in that pores will get evaporated. So in that case it leads to the formation of the cracks ultimately. And also there is one important point, that it reduces the resistance against the sulfur attack. Okay, it reduces the resistance against sulfur attack. Its percentage varies actually between 4 to 14%, and average value is 11%, as same that of the tetracalcium aluminum ferrite. Okay, this is also average value, sometimes it is given that 11 or the 14%. So these are the values. So the next one is the tetracalcium aluminum ferrite. It also fast setting, but its role is actually negligible. Okay, its role is actually negligible if we consider the reaction of this compound. The next one is the tricalcium silicate. This tricalcium silicate, that is C3S, and dicalcium silicate, that is the C2S, these two are actually main strength imparting constituents. Okay, these are actually the main strength imparting constituents. So we will see about that in tricalcium silicate the strength development may be up to the 1 month. Okay, but in any case it is less than 1 month, that means it may be up to 1 week or the 2 weeks. And that I said already that early strength development in case of the cement is due to the tricalcium silicate, correct, tricalcium silicate, and the latter is due to the dicalcium silicate. Okay, dicalcium silicate. Now let's move to the next question. So the next question here is what is the question? That is, leachate layer apparatus is used for testing cement. Actually, based on this testing of the cement, no questions have been asked, but just for intro or to know about that point, we have taken this question. So the question is, leachate layer apparatus is used for testing the cement for its soundness, correct, it is used for the soundness. Now the next question is, we are not going to detail in that, it is again on that point, that is the leachate layers apparatus, and what they are asking, that increase in the distance between the two indicators. So you know that the leachate layers apparatus is something like that, and this distance actually they are asking. So that should not be more than, what they are asking, that should not be more than, and the correct option here is option B, that is the 10 mm. Okay, that is the 10 mm is the correct option. That means in that case the cement will not be unsound. Okay, now the next question here is, it is very simple question. You can see that is the 43 grade cement has a strength 43 Newton per mm square at the edge. A very simple question. Okay, so these are asking about the strength, the strength is given and they are asking the age. So the correct option here is 28 days. You all know about that. Here the table. Now the question may be asked these 43. Okay, they may ask the strength of this 43 grade cement at the 7 day, or they may ask find what is the strength of this 43 grade cement at the age of 3 days. So here is the table, and these grade of cement actually, these are the IS codes. Okay, this is for 33 grade, this is for 43 grade, and this is for 53 grade cement. Okay, that is IS 269 for 33, IS 8112 for 43, and IS 12269 for 53 grade cement. Here is the table showing the variation of the strength. Okay, at the time of their age, or we can say that depending upon their ages, that strength should not be less than these values. Okay, so this is the strength, this is the grade MPa. So there is the 33 grade, 43 grade, 53 grade, and their values should not be less than these values in any case. Suppose take the first case over here. What is the case? So 33 grade cement and 3 days strength, it should not be 16 MPa in any case. Okay, similarly for 43 grade cement, the 3 days strength should not be less than 22 MPa. Similarly for 53, 3 days strength should not be less than 27 MPa. So remember these tables. Question may be framed on such a type that 43 grade and 7 days strength. Okay, we will discuss in the next session about that. So this is about the basic question. Now let's move to the next question. So the next question here is the normal consistency of cement is about. So they are asking about the normal consistency of the cement. Okay, so the correct option here is option D, that is the 28%. Okay, 28% is the normal consistency of cement. There is no any explanation for that question. So now the next question is, addition of pozzolana to Portland cement causes. Addition of pozzolana to Portland cement. Portland means that is the general OPC cement, and when we add pozzolana, what is the pozzolana? These are the pozzolana materials, such as these are nothing but the siliceous materials. Okay, these are siliceous materials, and these doesn't have any inherent binding property. Okay, these materials doesn't have any inherent binding properties, but when they are mixed with this Portland cement along with the water, they gains the binding property. Okay, they react with that calcium hydroxide and form the calcium silicate hydrate gel. Okay, so the question is, addition of pozzolana to Portland cement causes. So they are asking what is the effect when we add pozzolana to this Portland cement. So read one by one what are the options given here. So the very first option here is the increase in heat of hydration. The second option is increase in strength. The third option is increase in water tightness, and the fourth option is all of the above. Now these pozzolanic material are added, in that case the strength actually does that much, there is not that much effect in case of the strength. Okay, that means we can say that almost the strength will remain same. So this is not the correct option. So the next option here is the increase in the heat of hydration. Now when we add this pozzolanic material, actually this heat of hydration is get reduced. Okay, this heat of hydration will get reduced. So this option A will be not correct option. Then option B is the increase in the strength. This is also not the correct option. So the most correct option here is appropriate option here is the C option, that is the increase in the water tightness. Increase in the water tightness, this is the correct option. Okay, now next move to the let's move to the next question. The question here is about the blast furnace slag cement. Okay, blast furnace slag cement. So what is that blast furnace slag cement? Is actually it consists of granulated, it consists of this granulated blast furnace slag. So what is this slag? Actually when the this is nothing but the byproduct. Okay, this is the byproduct from the blast furnace. Blast furnace is a type of furnace, and this granulated blast furnace slag is the byproduct. Okay, and this byproduct is used in the OPC, and its percentage may be vary between 25 to 65%. Okay, this percentage of the okay, this percentage may be vary from 25 to 65%. So this is about the blast furnace slag cement, and these are certain advantages of this blast furnace slag cement. So what are these different advantages? Due to this blast furnace slag cement, the workability of this concrete get increases. Okay, the workability get increases, then durability also increases in this case. Okay, the durability is also increases, and as I said, it is the byproduct. That means it is cheaper as compared to the other materials. Okay, so it is the cheaper, one of the cheaper constituent. So if you see the options here one by one, the first one is the durable, this is the correct option. The next one is the gain strength slowly, this is also the correct option. That blast furnace slag cement actually gains strength slowly, that means it's at less heat of hydration. And the next option is C option is cheap, correct, it is cheaper as it is one of the byproduct. Okay, so the correct option here is option D, that is all of the above. Correct, all of the above. That means blast furnace slag cement is durable, is also a cheaper one, and it's also gains strength slowly. Okay, so this is about the blast furnace slag cement. Now the next question here, read carefully. The question is, which one of the following is not correct? Okay, focus on this point, that is the not correct statement about fly ash blended cement, about fly ash blended cement. So in this case actually they are asking the incorrect, about the incorrect statement. So if you see this fly ash is nothing but a pozzolanic material. Correct, it is also a pozzolanic material, as already discussed about this pozzolanic material, that these react with water and cement, and they they provide the cementing properties. Okay, they do not have the inherent properties, but they reaction with the water and the cement, they develop that property. Okay, so one by one we will read the questions and identify the correct option. So the first question is, they have superior resistance to weathering action. The next option is here, they gain strength fast. Okay, they gain strength fast, and the next one is ultimate strength is same as OPC, and the last one is all of the above. Now I have already told that the ultimate strength is almost equal to that OPC. Of course it is somewhat greater in latter cases, but this is not the case. So we can say that ultimate strength is same as OPC. This one is the correct option. This one is the this one is correct if we consider the fly ash blended cement. The next one is, they have superior resistance to weathering action. This is also correct, because this fly ash actually the pores, they blocks the pores. Okay, they blocks the pores that are present. That means they react with that calcium hydroxide. Okay, this reacts with calcium hydroxide and form the cementing gel, that is CSH, that is calcium silicate hydrate. So ultimately they leads to the superior resistance to weathering action. Okay, so the option remains here, the option B. Okay, option remains here, option, that is they gain strength fast. As I already told that their strength development rate is slow. Correct, their heat of hydration rate is slow. So the correct option here is option B, that is they gain strength fast, is the incorrect statements if we consider the fly ash blended cement. Clear? Okay, so next let's move to the next question. So the next question here is about the rapid hardening cement. Okay, it is about the rapid hardening cement. Now read the question carefully. So they have given the first option is the increasing the lime content. They are asking how it is produced. Okay, rapid hardening cement is produced by, the first option is increasing the lime content, the next option is burning it at a high temperature, and the third option is grinding to a finer size, and the last is the all of the above. Now let's discuss about this rapid hardening cement. So this rapid hardening cement is actually, it contains the more lime. Okay, it contains more lime as compared to the OPC. So this one, the first one is the correct option, we can say. Now the next one is this, that is burning it at a high temperature. This is also also the correct option. Okay, burning it at a high temperature is also the correct option, and the last option, that is the grinding to a finer size, this is also the correct option. Okay, so you can see here that the both above three options are correct. So ultimately this D option, that is all of the above, is the correct option for this question. Now what is it RHC? So in that case, the rapid hardening cement, let's see some of the properties of this rapid hardening cement. So this rapid hardening cement actually have higher percentage of C3S, and the lower percentage of C2S. Now if you see these bogus compounds, you know that in case if this C3S content is more, that means this, we have discussed that strength development due to this C3S in early stages is more, correct, more, or you can say that initial stage strength development, and this is about this lasts about a year. That means it is this is ultimately leads to the what we say for that, this is ultimately leads to the long time strength, you can say that long time strength, and that is the ultimate strength, and you can see here it is the rapid hardening cement. That means obviously here the percentage of C3S is more if you compare to the C2S. Now talking about its initial setting time and final setting time, actually most of the students get confused with this, its naming, that is the rapid hardening cement. That means they say it will hard rapidly, that means sets quickly, but this is not the case here. Here it's if I say its initial setting times is also remains same, that is the 30 minutes, and final setting time also same as that of the OPC. From this you can say that there is no any change in initial setting time. Okay, its initial setting time remains the same, but just the strength development in case of the rapid hardening cement is more as compared to the ordinary Portland cement, and in that case the 3-day strength of this RHC, that is rapid hardening cement, is equals to the 7-day strength of the OPC. Okay, that is the ordinary Portland cement. So this is the case about the rapid hardening cement. Now the next question here is, the which statement given below is wrong? Okay, they are asking about the wrong statement, and what are they asking? The pigment used to produce the color cement. Okay, so these are the different pigments given in the options, and the color imparted by these pigments when we combine with this the clinkers. Okay, so one by one we will read that. So cobalt oxide gives the blue color, this is the correct option. Okay, note down these points that these are the correct options, so you can get the wrong answer here obviously. So the next option is the chloride oxide to get the green color, this is also the correct option. The third one is the manganese oxide to get the brown color, this is also the correct option. So the option remains here is the fourth option, that is the aluminum oxide to get white color. So this is obviously the wrong option here. Okay, so this is the wrong option because these three above are true option, that is the cobalt oxide blue color, chloride obviously green color, and manganese the brown color. Now next move to the next question, and that is the, what is the question? Read the question. For testing compressive strength of cement, the size of cubes used is. So they are asking about the size of the cubes, and they have given the dimension. The first one is the 50 mm, the next one is the 70, then 100 and 150. So the correct option, you all know that the correct option here is B option, that is the 17.6. there is no need to explain that. Okay, so in that case you all know that in order to determine this compressive strength, the standard sand, that is the NOR sand, is used. Okay, NOR is the place, and you know in that case the sand to the cement to sand ratio is 1:3. So remember these points, okay, for testing compressive strength of the cement. okay, for testing compressive strength of the cement. Now the next question here, this is about the bulking of sand. Okay, bulking of sand. We will see after what is the bulking of sand. The question read that first. Due to bulking of sand, increase in volume is as high as. So they are asking how much increment in the volume. Okay, due to this bulking. So in case of the bulking, the increment is up to 38%. So we can say here the correct option here is, if you check the range, here is 5%, there is 15, here is 25, and here is 30 to 40. That means option D is the correct option over here. Okay, option D is the correct option here. Now the next question is, the maximum increase in bulk of sand is at the moisture content. So they are asking at what moisture content there is a maximum value of the bulking. So if you see the option, the first one is 2 to 4, the next one is 4 to 6, the third one 8 to 10, and the last one is 12 to 15. So the correct option over here is the option C, that is the 8 to 10%. Okay, this is from the experimental study that this value is between 8 to 10%. Okay, there is no any concept behind that. Now next another question, that is the which one of the following is not a desirable property of the sand. So they are asking, below are the options given, and which of the following is not a desirable property. Okay, so that means they are asking the requirement of a good sand. Okay, so read the options one by one carefully. The first one, so before that I have prepared here in the notes, that is the properties. Okay, requirement of this sand. So what are these? It should be clean and free from organic material. Then its grain should be sharp, angular, and durable. The third option is that should be inert nature. Inert nature, that means that should be chemically inactive. Okay, that means the sand particles should be chemically inactive. That means that doesn't lead to any type of the reaction when they are combined with water and cement. Okay, and the last one is the well graded. Why well graded? Because due to the well graded, the compaction of these sand molecules and the cement in a structural element actually shows the good behavior. Okay, good structural behavior. So the options, read carefully one by one. So the first option, it should be chemically active. This is the wrong option. Correct? It should not be chemically active. The next one is it should be contain sharp, angular, and this is also the one of the correct option. Why? Because there will be strong bond formation due to these sharp and angular grains. Okay, the next one is it should be hard. Correct, that should be hard. That's why the artificial sand, if you see, these are actually manufactured from granite and basalt. Okay, now the next option, it should be well graded. Obviously, that's why there will be good compaction. Okay, so the correct option here is option A. Okay, option A. And what is that option? Option A is it should be chemically active is the not a desirable property of sand. Okay, not a desirable property of the sand. Now the next question here, read the question carefully. The question here is the increase in volume of sand when water is added is known as. Okay, the increase in volume of sand when water is added is known as, and you all know that the correct option here is the bulking. Okay, when there is increase in the water content, there is also increase in the volume of the sand. Okay, so this is called as a bulking, and as we discussed that the maximum bulking occurs when the water percentage is between 8 to 10% moisture content. Okay, between 8 to 10%, and the maximum value of the bulking is up to 38%. Okay, it is up to 38%. And one of the important point over here is the bulking occurs due to the formation of the surface film above the particles. Okay, so suppose this is the particle, so around that particles what happens, suppose this is the particle, so around that particle there is surface film of water occurs, and due to that surface film, these molecules, these particles of the sand repulse each other, and that leads ultimately to the increase in the volume. Okay, that ultimately leads to the increase in the volume, and that's why there is the bulking phenomena. Now the next question here is the fineness modulus is. So they are asking what is the fineness modulus. So the first option is the ratio of fine aggregate to coarse aggregate. The next one is the ratio of fine aggregate to the total aggregate. The last one, the third one is an index which gives the mean size of the aggregate used in a mix, and the last one is the none of the above. Before that, let's discuss about the fineness modulus. So what is that fineness modulus? This fineness modulus actually represents the average size of the particle. Okay, it represents the average size of the particle, and how its value is given? Its value is given such from this equation, that is sum of cumulative percentage retained divided by 100. And what is that sum of cumulative percentage retained? It is obtained by sieve analysis. Okay, it is obtained by sieve analysis, and depending upon that, IS code 383 suggests the different zones, from zone 1 to zone 4, that is zone 1, zone 2, zone 3 and zone 4. And as we move from zone 1 to zone 4, this fineness actually increases. Okay, this fineness actually increases. And if you see the table here, that is the fine sand, medium sand, coarse sand, and the values of this is nothing but the values of the fineness modulus. Okay, these are the range, and the questions are actually can be asked on this topic also. So our question here is, what is the fineness modulus? So it can be clear from here that it is represents the average size of the particles, and the resemblance that you can see an index which gives the mean size of the aggregate used in a mix. Correct? So option C is the correct option here. Now the next question here is, with increase in moisture content, the bulking of sand. So they are asking with increase in the moisture content. That means suppose this is the dry sand, purely dry sand, and if I goes on increasing the moisture content, suppose from 10%, then 20%, then 30%, and then 40%. What they are asking, with increase in moisture content, the bulking of the sand. That means what will happen with the bulking of the sand? Whether it will be increased, it will be decreased. The third option, first increase to a certain maximum value and then decrease, and the last one is first decrease to a certain minimum value and then increases. Now if you see the bulking of the sand graph, then with increase in the water content, and suppose this is increase in the volume, and if I draw the graph over here, so this is something like this. Okay, this is something like this. So in that case, this value actually, for the first, as we increases from this portion, suppose from 0, then in that case it goes on increasing. Okay, the volume goes on increasing, and at a certain peak it gets this value. After that, when I again increase, if I increase the water content, then in that case the volume will get reduced. Okay, the volume will get reduced. That means the correct option here is the option C, that is the first increases to a certain maximum value and then decreases. Okay, first increases to the certain maximum value and then decreases. Okay, so this is the correct option here. Now let's move to the next question. So the next question here is, which of the following cement is suitable for, read the question, which of the following cement is suitable for use in massive concrete structure? This is the keyword here, massive concrete structure such as large dam. So in case when you have to construct the large massive structures, okay, bulky structure, so in that case which type of the cement you will use? So they are asking about that. So the option first here is the ordinary Portland cement, the next one is the low heat cement, the third one is rapid hardening cement, and the last one is the sulfate resisting cement. Now in case of the large dams, there is bulk structure. Suppose this is the structure of the dam. So in that case what happens, there is a large mass of this concrete, or you can say as a cement. So the hydration process as processes, so in that case heat of hydration will evolve. Okay, so that due to that heat of hydration, the water will converted in water in the pores will get converted into water vapors, and it will ultimately exert the pressure on this surrounding area. Okay, ultimately it exerts the pressure on this surrounding area. There is also increase in the temperature. Correct, at the core there is also increase in temperature, and due to that the water vapors will generated, and that leads to the processing towards the surface and producing the tension. Okay, it will producing this tension, and we all know that it is cement or concrete is weak in tension. It will ultimately leads to the cracks. Correct, it will ultimately leads to the cracks. And do these cracks are allowable in such an important structure such as the large dam? Obviously no. So in that case, which type of cement you will? Obviously the cement which will have the low heat of hydration. Okay, low rate of heat of hydration. So the correct option here is option B, that is the low heat cement. Okay, this is the low heat cement is the correct option over here. Now the next question is high percentage of tricalcium silicate, that is C3S, and low percentage of dry calcium silicate, that is C2S, in cement results in. So what it results in, if I increases the percentage of C3S and reduces the percentage of the C2S. So one by one read the option. Okay, one by one read that option. So the first option is rapid hardening, it is correct. correct na? As we all know that C3S actually developed strength and hydrates at a faster rate as compared to the C2S, and most of the strength at the initial stages up to the 1 month is due to the C3S. So the option first, that is the rapid hardening cement, is the correct option. Rapid hardening, as we discussed in rapid hardening cement also, that in that case also the percentage of C3S is higher, and that's why the strength development is rapid as compared to the ordinary Portland cement. The next one is the high early strength. This is also one of the correct option. Okay, the next is the high heat generation. Obviously C3S hydrates percentage is increased, that means the heat of hydration it is more in case of this, that is the high heat generation. So ultimately the option D is the correct option, that is the all of these, that is there will be also rapid hardening, high early strength also again there, and there will be also high heat generation, there will be also high heat generation. Now the next question here is about the blast furnace slag cement. Okay, it is about the blast furnace slag cement. So what is this? The options given are, what is the question? The blast furnace slag cement. Okay, the option first is develops low heat of hydration, has less early strength, develops high heat of hydration, and has high early strength. If you remember, I have discussed, I think in the third or the fourth question, about this blast furnace slag cement, and at that point I have said it generates or develops low heat of hydration and it has less early strength. So here option A and option B both are the correct option. Okay, these both are the correct option. Now next move to the another question. So the question is, for a structure subjected to the action of sea water, the cement used is. So they are asked, in case of the any marine structure, what type of cement you will be used in that case. So the first option is the rapid hardening cement, the next one is the low heat cement, the third one is the high alumina cement, and the last one is the sulfate resisting cement. So let's check one by one option. The first option is rapid hardening cement. Yes, this is rapid hardening cement also has somewhat sulfate resistance or the resistance against somewhat chemical attack. So this may be the option. Now the next option is the low heat cement. Now tell me, in case of the marine structure, okay, action of the seawater, the strength development should be higher. So in that case, low heat cement should not be used. This is not the correct option. The next one is the high alumina cement. If you see the characteristics of this high alumina cement, then in that case, this high alumina cement is actually more susceptible to this chemical attack. Okay, this is more susceptible to this chemical attack. Actually in this is like ordinary Portland cement what we use, that is the calcareous and argillaceous substances, correct? Here also limestone and bauxite is used. Okay, that is alumina, bauxite is used, and the corresponding cement form is nothing but the high alumina cement. Okay, high alumina cement, and this cement is actually more vulnerable to this chemical attack. So this is also not the case. We should not use that cement in case of the marine structure. So this is also incorrect option. And the last one is the sulfate resisting cement. This is the correct option. So between option 1 and option last, that is A option and D option, option D, that is a sulfate resisting cement, has more resistance. Okay, when a structure actually subjected to alternative drying and wetting process, then in that case this sulfate resisting cement is actually behaves best in manner if you compare to the other cement. So which may be in case of the foundation, okay, foundation where it is in contact of the soil. So in that case the sulfate resisting cement is the best option. Okay, so in that case the percentage of the C3A is limited to 5%. Okay, limited to 5%, and similarly for C4AF, that is tetra calcium aluminoferrite. Okay, so this is about the last question, that is the structure subjected to the action of the seawater. So this is about the questions we have discussed far. And I think these are almost 30 questions we have discussed over here regarding the cement and the sand. And next module also we are going to discuss some of the high difficulty level questions. Okay, some of the high difficulty level questions. So for today's lecture it's end here. So thank you.